The contaminants of emerging concern are certain substances that are widely present in the environment and that they can cause potentially severe effects on human health or the environment, and that is why the current legislation is focusing on them and started to regulate them. They are called of emerging concern, not because they are new, because they have been present in the environment for quite a while now, but because with the latest advances in technologies, we're able to detect them, although they're in very small concentration or low concentrations. And the proportion would be like a teaspoon in an Olympic swimming pool. So now with the advances in technology, we can monitor them and be aware of them, but also try to eliminate them. The project has a very ambitious goal, that is to eliminate up to 80% of the contaminants of emerging concern in two different scenarios, drinking water and wastewater scenarios. And for that, the first step was to characterize which contaminants were present in these scenarios. For that, we started to do an analytical campaign that took 1 year long. And so we analyzed different families of CECs, the pharmaceuticals, pesticides, industrial chemicals, but also microplastics and antibiotic-resistant genes. And the idea was to select the ones that were more relevant for the demonstration of the solution. And for that, we were paying attention to concentrations, frequency, and also the seasonality, etc. And also we needed to know in which operations we needed to operate, so we did a physicochemical characterization as well of the water. Regarding the operation of the plant, we will have a pretreatment in the wastewater scenario, so we could operate. And the drinking water scenario has a very particular characteristic because we're taking water from the river, so it fluctuates along the river with rainy seasons. But we will operate the plant when the conditions will allow it. So in just punctually scenarios where the quality of the water is not enough, we will stop operating the plant. And regarding contaminants, we found out that we need to measure along the year to have seasonal trends as well, because, for example, some pesticides are only detected at some point of the year specifically because they are added to the crops. Regarding the contaminants, the family that was mostly detected were pharmaceuticals. And regarding pesticides, the most relevant pesticide was glyphosate, and microplastics, it was polyethylene, all in both scenarios. We detected antibiotic-resistant genes in the rivers. Regarding antibiotic-resistant bacteria, it was eliminated in the wastewater treatment plant, but the genomic DNA containing antibiotic-resistant genes was not eliminated, so it will be the focus of the project to try to eliminate it. For a more continuous monitoring of the contaminants, we have developed a sub-sensor based on artificial intelligence that will estimate the concentration of the contaminants at the entrance of the pilot based on physicochemical measurements that will be taken with online sensors. And for a validation of the sensors, we will be taking samples at the inlet and outlet of each individual technology, but also of the whole technologies as a whole. And we will be sending these samples back to ACCIONA lab. In ACCIONA lab, we will analyze them with a liquid chromatography coupled to mass spectrometry instruments that give us a high confidence in the detection and quantification of these compounds. And this way we can feed again the sensor and optimize it.